Have you ever wondered how engineers manage to build tunnels that run deep beneath massive rivers, connecting cities and communities that would otherwise be separated by water? The idea of carving a path under a river might sound like something out of a science fiction novel, but it's a real-world challenge that engineers have been tackling for over a century. These tunnels are not only marvels of modern engineering, but they also play a crucial role in transportation, commerce, and urban development. Today we'll take a closer look at the fascinating process behind building tunnels under rivers, and explore the incredible ingenuity and teamwork required to make these projects a reality. We'll dive deep into the technical processes, the engineering challenges, the safety protocols, and the environmental considerations that shape every stage of construction. Along the way, we'll highlight some real-world examples that showcase the remarkable achievements of tunnel builders around the globe. The process of constructing a tunnel beneath a river is a remarkable feat of modern engineering, combining advanced technology, meticulous planning, and the expertise of countless professionals. From the very first sketches to the final touches, every step is carefully orchestrated to ensure the tunnel is safe, durable, and able to withstand the immense pressures of the river above. These projects often take years to complete and require the collaboration of engineers, geologists, construction workers, and environmental specialists. The result is a structure that not only serves a practical purpose, but also stands as a testament to human determination and creativity. But what exactly goes into making these underwater passageways possible? Let's break down the methodologies and the science behind them. The journey begins long before any digging takes place. First, teams of engineers and surveyors conduct detailed surveys and planning sessions to determine the safest and most efficient route for the tunnel. They analyze the river's width, depth, and current, as well as the geology of the riverbed and surrounding land. Soil samples are collected and tested to understand the composition and stability of the ground. Advanced computer models are used to simulate different scenarios, helping engineers anticipate potential challenges such as water pressure, shifting sediments, or the presence of underground obstacles. This phase is critical, as even a small miscalculation can lead to costly delays or safety hazards later on. In addition to technical analysis, engineers must also consider the impact on local communities, existing infrastructure, and the environment. Public consultations and environmental impact assessments are often required before construction can begin, ensuring that the project aligns with regulatory standards and community needs. Once the planning is complete and the route is finalized, the real work begins. In many cases, engineers deploy giant tunnel boring machines, or TBMs, to dig beneath the riverbed. These machines are truly massive. Some are longer than a football field and weigh thousands of tons. As the TBM moves forward, its rotating cutter head grinds through soil and rock, while a conveyor system removes the excavated material. At the same time, the machine installs precast concrete segments to reinforce the tunnel walls, creating a sturdy, watertight passage. The TBM operates under high pressure to prevent water and mud from flooding the tunnel, and its progress is carefully monitored by a team of operators working around the clock. TBMs are equipped with sophisticated navigation systems, allowing them to stay precisely on course even as they travel deep beneath the river. The pressure inside the TBM is carefully balanced to match the external water pressure, preventing dangerous blowouts or collapses. In some cases, engineers use a technique called slurry shield tunneling, where a mixture of bentonite clay and water is pumped into the tunnel face to stabilize loose soils and control groundwater. This method is especially useful in soft or sandy riverbeds, where traditional excavation could lead to cave-ins or flooding. In some situations, especially when the river is particularly wide or deep, engineers use a different technique known as immersed tube tunneling. This method involves constructing huge tunnel segments, often made of steel or concrete, at a separate location, sometimes miles away from the river itself. Once completed, these segments are sealed, floated down the river using barges, and carefully positioned along the planned tunnel route. Massive cranes and winches lower each segment into a trench that has been dredged in the riverbed. Divers and engineers then connect the segments together, ensuring a watertight seal. Once all the segments are in place, the trench is backfilled with gravel and sand to secure the tunnel, and the interior is finished to accommodate vehicles, trains, or utilities. Immersed tube tunnels are often used for projects where traditional boring would be too risky or expensive, such as the Öresund tunnel between Denmark and Sweden, or the Marmaray tunnel beneath the Bosphorus in Turkey. These projects require precise coordination, as even a small misalignment can compromise the entire structure. Engineers use GPS, sonar, and laser-guided systems to ensure each segment is perfectly positioned before being joined together. Throughout the entire construction process, safety and environmental protection are top priorities. Engineers must constantly monitor for signs of ground movement, water leaks, or equipment malfunctions. Workers are trained to respond quickly to emergencies, and strict safety protocols are enforced at every stage. In addition, special measures are taken to protect the river's ecosystem. Barriers and filtration systems are installed to prevent construction debris or pollutants from entering the water. Environmental experts monitor the health of local wildlife and water quality, making adjustments as needed to minimize the project's impact. These efforts ensure that the tunnel not only serves its intended purpose, but also preserves the natural beauty and health of the river environment. For example, during the construction of the Thames Tideway Tunnel in London, engineers implemented advanced water treatment systems and scheduled work to avoid disrupting fish spawning seasons. In Norway, where environmental stewardship is a national priority, tunnel projects often include extensive habitat restoration and long-term monitoring programs to ensure the river and its surroundings remain healthy for generations to come. When the tunnel is finally complete, it stands as a symbol of what humans can achieve through innovation, collaboration, and perseverance. These incredible tunnels connect cities, enable rapid transportation, and open up new possibilities for trade and travel. They help reduce congestion on bridges and ferries, making daily commutes faster and more reliable. More than just concrete and steel, river tunnels are a testament to human ingenuity, a reminder that with enough vision and determination we can overcome even the most daunting obstacles and build a better, more connected world for generations to come. Some of the world's most famous river tunnels, like the Lincoln Tunnel under the Hudson River in New York, the Second Tunnel in Japan, and the Channel Tunnel between England and France, have transformed the way people and goods move across continents. Each project faced unique challenges, ranging from unpredictable geology to political hurdles, but all succeeded thanks to the dedication and creativity of the teams involved. As technology continues to advance, future tunnels may be built even deeper, longer, and more efficiently, opening up new frontiers for human exploration and connection. So the next time you travel through a tunnel beneath a river, take a moment to appreciate the incredible journey that made it possible. From the first surveyor's stake to the final bolt in the tunnel wall, it's a story of vision, teamwork, and the relentless pursuit of progress. Let's recap the key steps and innovations that make river tunnels possible. It all starts with careful planning and surveying, followed by the selection of the best construction method, whether it's tunnel boring machines carving a path deep below the riverbed, or massive immersed tube segments being floated and sunk into place. Every stage is guided by rigorous safety standards and a commitment to protecting the environment. The result is a structure that not only connects people and places, but also demonstrates the power of human ingenuity. As we look to the future, the lessons learned from these projects will continue to inspire new generations of engineers, builders, and dreamers. River tunnels are more than just infrastructure. They are monuments to what we can achieve when we work together to solve the world's toughest challenges.